So today we're going to be talking about bearings. A bearing is the bearing of a line is the acute angle formed by the north and south axis on the line, rather than the east and west, which is what we've been doing. So here are some notations for it. You can do north 34 degrees east. In that case, you draw your axis and just label it like a compass. North, east, south, west. And then you look for north, then east, and you draw your line. And then you connect it to your north axis. And right here,
I can't see.
this angle is your bearing, which would be 34 degrees.
What's a bearing?
A bearing of a line is the acute angle formed by the formed by the north and south axis. Okay? When you draw normal triangles, you connect them at the x-axis always. For bearings, you only connect them at the y-axis.
Why?
Because that's just the way they work. So if you were to do south 73 degrees west, you would do, again, the normal.
How do you know where the bearing is?
The bearing is what connects the two lines to the north and south axis.
Okay, well, let me ask a question.
Yes.
Why would you put it right there instead of right there or right there?
Because this is the 90-degree angle,
Okay.
and this isn't attached to
Right.
y-axis.
Right. So, do we have to actually draw it as if it is 43 degrees? Because how can I do that?
Not accurately in this case, because we can't really accurately do that.
Understandable.
But, I mean, don't draw like 3 90-degree angles, you know?
Right.
Whatever. So south and west.
Hold on, you put out.
Yeah. So if your bearing was south 73 degrees west, where do you think we're going to draw that line?
Over here in the second quadrant.
Okay, well, why?
Or the northwest.
I said south.
Oh, this one,
73
this one,
west.
this one.
Yes. Okay.
I don't know which quadrant that is actually.
This is the fourth.
Really?
No, it's
Third.
the third. That was backwards. So, do you know what line we're going to connect this one to?
Huh? Yeah, it's gonna go like this. Let me see yours. Here.
And then
Okay, but
this
no.
angle right
How
here.
would you know to do up or this way?
Which way?
This way or this way?
Because you only connect it at the north and south axis.
Ah, no, you said that. Okay, so there's the bearing right there.
Yeah, you know what the bearing is.
Yeah, it is E.
73 degrees. Okay, so we have an example down here. Gotham City is 14 miles due north of National City. If Metropolis is 3.5 miles due east of National City, what is the bearing from Gotham City to Metropolis?
Oh, let's start drawing.
So let's draw my axis. So if we start right here, and we have Gotham City, that's where we're starting.
Okay.
That is 14 miles due north of National City. So down here, 14 miles, we have National City. And then, if Metropolis is 3.5 miles due east,
From what?
due east of National City, so we're going to have 3.5 over here. It's asking what is the bearing from Gotham City to Metropolis. So we want to know what this angle is, or this angle. Because we have these two sides, and because we know that tangent.
Well, we want to know the bearing.
Right. But we don't know any angles yet.
Right.
So because we know that tangent is opposite over adjacent, we can do that tangent of theta, which is what we're going to call this angle for now, equals the opposite, which is 3.5, divided by the adjacent, which is 14. Okay, so then we want to get theta by itself. In order to do that, we have to take inverse theta of both sides. And when we do that, that cancels out theta, or cancels out tangent on this side. So it's theta equals the inverse of tangent, 3.5 divided by 14. And then we plug this into the calculator, which we can do really quick, which is second tangent, 3.5 divided by 14. That gives us 14.036.
As the bearing.
However, we round it to just 14. So our bearing would be southeast, and the bearing degree is 14. So it's south 14 degrees east.
Got it.
So that's your bearing.
Cool.
Do you have any questions?
I did, but you answered them along the way. Oh yes. How do you know when to use sine, cosine, and tangent?
So right here, we know the opposite side and we know the adjacent side, which means we can only use tangent in that case. However, if we knew the hypotenuse, in this case, instead of the opposite side or something, we could use cosine.
Right.
It just matters which side you have and which angle you have.
Yes.
Is that it?
Cool. Thanks, Miss Taylor.